Ishan Rao. I'm a PhD student from Indian Institute of Technology, Tirupati. This is my 12th and last interaction session for data analytics with Python, and in this session I'm going to touch few machine learning algorithms which has not been touched in the syllabus, but implementation wise, and you should know quite a little bit about those algorithms. So I'm going to touch upon that. So that is random forest, gradient boosting, and ADA boosting. So if this sounds useful to you, please stay with this, and during the end of the session we can have a interaction about like what to do after doing this course. Okay, so today's topic will be mostly discussion about the three supervised machine learning algorithms, supervised and supervised machine learning algorithm, followed by its small implementation for the small sample size data. So let me share the screen. Okay. Fine. So I'm going to discuss three concepts today, three algorithms. Let me change it. Three algorithms. So first will be random forest, through which we can make something called from which we are derived algorithm called AdaBoost algorithm, through which we are derived for gradient boosting. So these are related, and base will be random forest, whose base is basically a decision tree. Now decision tree, we have covered that concept in the last session, so I'm assuming that you might know a little bit of decision tree here. Okay, so we'll start with random forest, followed by AdaBoost and gradient boosting, and we will do a small implementation for each of these algorithms. That's how we are going to start. Okay, now let's start with random forest. Okay, now random forest is basically a decision tree. It's typical decision tree, but as the name suggests, it's varying. The size of the trees that is going to make is very varied. So let's talk more about that. So first is they made out of decision tree. Now decision tree, in a simple in a quick summary, you will have some n features, right? So what decision will take? It will take feature number, suppose 2. It will split from feature number 2, and it will try to create a tree where at each node it is splitting based on certain feature 6, something like that, to reach to a certain decision. So it use decision tree is basically a try to make rules out from the data set, and try to at each node try to split the features with certain thresholds, and then try to arrive at the leaves. The leaves will follows the target variable of the particular data set. That's a brief concept of decision tree. Now the problem with decision tree is that it might overfit the data. Overfit the data means there are quite instances where it is trying to exactly understand the training of that data. So, but once the new data will come, it will mostly fail. So, at this kind of scenarios, decision tree might not be useful. So, when it comes to classifying new sample, it might not work. So the goal is basically for random forest is to uh, combine, since it is simple to make, so combine the simplicity of the decision tree dt I'm writing, plus plus the flexibility in resulting. So the flexibility will come in this case when we flexibility is saying that there will be number of trees in random forest, because forest is basically made of trees. So there will be n k number of trees of varying size. So that's how it will be. It will be based on varying size, and which will help us to improve the accuracy. And when we are saying accuracy, we mostly talk about when we are trying that we are trying the model on a new data. So that's where we use the term accuracy at that point of time. Okay, so let's to do that, let's assume we have a data set, a certain data set. So a data set might be a heart disease data set. So we might have column like uh, chest pain, good blood circulation is there or not, block arteries, weight of that person, and whether it has heart disease or not. So just like we will have certain values with respect to that. This here you can make a decision tree out of like that. But how to make a random forest? So for the random forest, what you will do is step one. You try to create a bootstrap data. So let's assume the table that we have created earlier might have 8 entries. Now from here you will try to create a bootstrap data set. It will also contain 8 entries, but the only difference here will be that we are allowed to pick the same sample more than once. So assume that we have here which is the original data set. This is the original data set. Here we might have a distinct records, but when you are applying for the when you're going for the random forest process, then you might have duplicate records. That means for the same record will be present multiple times, 2 times, 3 times, and number of times. So that's first step. We will create a bootstrap data set. Now this is done to make it more to bring randomness by creating a decision tree where a particular kind of record, or in this case we may say sample, will give uh, more weightage to certain kind of records because they are more frequently coming in that data set. So that's why to giving weights to different kind of samples, because they are occurring more and more, there's high chance that it might give certain weights to certain variable or certain records like that, and it will do hundreds of times. So we will go to that. So once it create a bootstrap sample data set, so it will go to step 2. Now what we'll do is we will create a decision tree. We'll create a decision tree. Now the using this bootstrap data set. Now what the interesting part we will do here is, from this bootstrap data set, instead of taking all the variables, for example we have 4 variables and one target variable in the original data set. In bootstrap data set also 4 variables and one target variable will be present. The only difference that where it will come here is, in random forest decision tree, I'm trying dt, I can take random subset of variables. So that means if I have a table of x1, x2, x3, x4, and this is the y is a target variable, I might choose only x2 and x4 as my variable, and y as a target variable. So using these three columns, I'm going to make a decision tree. So once I've made this, so my new data set will come here from Bootstrap, which will contain only x2, x4, and y. From here, I will try to make a decision tree. Now from here, I will get a certain kind of decision tree. Will something look like this? A certain of certain size. Like, we don't care about size right now because we are not specifying the depth here. In random forest, we don't specify the what is the depth of the tree should be like, so it will automatically create on its own. So once you're creating multiple this subtree, this is the first process. This will be the decision tree one. Okay, but you will do this whole process hundreds of times. So step one, create a random bootstrap dataset. Step 2, from that new dataset, select randomly uh, x m number of variables and repeat the process and make hundreds of decision tree based on that. Now once we create this, uh, for each time, for each iteration, we will get we'll get a new decision tree. Okay, so decision tree might be like this, like this. Size doesn't matter here. The depth of the tree doesn't matter at all here. Okay, so like that, hundreds of this thing will be there. Now this variety makes this random forest, a variety of decision tree, make it very effective to for prediction purpose. Okay, so now once we get this, uh, how it will evaluate. So once you get hundreds of decision tree and you collectively tell them as a random forest, so how you will evaluate that, or how will you say that, how the model will tell that, okay, for a particular record, whether target variable is there or not. So for those kind of conditions, what it will do is, let's take the original dataset variables name once again. So good but circulation, block arteries, weight, and heart disease. Now this was my the variables of data set, and I have some values like yes, no, block arteries, no, weight is 168 lbs, something like that, and I have to find out what is it, heart disease or not. So what it will do, it will go and to all those decision trees, hundreds of decision trees, and it will tell whether heart disease yes or heart disease no. It will first try to find out of all the decision tree, it will first try to classify whether which trees are saying yes and which saying a no. In that also, it will also try to predict which one is correctly predicted and which one is incorrectly predicted for both. Okay, so for this yes group and no group, it tried to find an n number of trees. So for example, 100, we have 100 decision tree, so maybe 60 will say yes and 40 will say no. In that 60, might be 50 will it will correctly classify as yes, or incorrect will be like that. If disease is no, it will correctly classify in maybe 25% and incorrectly by 50%, 15 instances. So once you have this, then what you try to do is you will just take which one is maximum and max and all these four options, which one is maximally giving the correct answer. So based on that, since in hard disease yes, correct, that it's correctly classifying yes if this condition is there. So overall it will produce that as a yes value, hard disease yes or no. Okay, so again to repeat, uh, so suppose you have the target test data with four variables and you want to check whether it's a hard disease or not. It will iterate to hundreds of decision tree combined together random forest. It will go there, then it will try to see uh, which tree is predicting yes or no, because each tree we are giving same weightage. Each tree will give same weightage. Okay, so we're giving same weightage. After that it is trying to say whether it's correctly predicting or not with the value, and then based on whichever the highest number of trees giving the particular correct answer, based on that it will predict that whether it's a yes or no. Okay, there's another terminology with respect to this random forest which is called as bagging. So bagging basically tells us that bootstrapping the data, plus using aggregate to make a decision, aggregate values, like we are considering all the trees answer and then we are aggregating it to make a final decision. So it is, this concept is called bagging. Okay, this another thing that we usually do apart from this, apart from accuracy, F1 prediction and all that, is something called as out of bag data set. Now what this out of bag data set do is, now while you're creating bootstrap data set, there's a very frequent phenomena that it will not collect all the instances. So suppose I have 100 instances in that original data set, there's a high chance that one third of them will not be included in bootstrap data set. So what they will do, this one third of samples will make us as a validation or test samples. Now we will use this out of bag, which can this one third of samples which call as out of bag samples. Now this one third of samples we will use to test uh, that whether the random forest is correctly predicting or not. Okay, so that is another way. Now another point with this last point with respect to random forest that we have to look at it is, when we are creating a tree here, yeah, when we are creating a tree, we randomly chooses two variables. So what if I want only one variable or two variables or three variables or four, all the four variables were to construct a tree? So how to do that? So this aspect also has been taken care by a random forest algorithm. So what it will do is, it will build a random forest using certain preconditions. Now based on that it will estimate the accuracy of random forest. After that there's a loop will happen where we are changing the number of variables in the number of features used per step. So I might start with one variable, then I might increase to two, then I might increase to three variable, four variable, till the n number of variables that we are having, and we keep on the random forest will keep checking all the possibilities to see that which one is giving random forest its best accuracy. Once it do that, it will produce as the final result. It will happen, all this thing happen during the fitting of the function. When you write a particular model dot fit, at that time all this process will be happening in the background. That will take care of by the algorithm by itself. Okay, so that's the overview of random forest. Let me again summarize what we do in random forest. So random forest is basically made out of decision trees. Now decision tree has a major problem of overfitting of data. Now, so what random forest do is it will try to get multiple decision tree with totally random with a totally random ways of doing it. That is taking number of different kind of samples, different kind of variables. All those things will come into consideration while building a tree, and each tree might be different from the other, but all the trees will be have a same weightage. So I might have a tree of depth 2, I might have a tree of depth 7 also in the random forest. Now to do that, the first step that we do is we create a bootstrap data set. That means I will create if I have a n samples for an original data set, I will create an n sample for bootstrap data set as well. The only difference will be for a typical entry, I might have a duplicate entry in the bootstrap, but I might, which is not possible in the original dataset. In the original dataset, I might have all the distinct entries, but in bootstrap, I might have duplicate entries as well. Okay, so once we have this, we try to create decision tree. In decision tree, the next step we will select the bootstrap dataset, and from that we will randomly select some subset of variables. Like that means out of 4 I might take 2 or 3 variables, and from that I will try to create decision tree. So once I create decision, that will be decision tree number 1. I will do this process of step 1 and step 2 hundreds of time to create uh, different data set and create decision tree using different number of variables. Now to evaluate what I will do is I will take a test sample instance. From there I will apply the 10 samples to hundreds of trees that have been created in the random forest, and I will see what is the final output predicted value. So from each tree I will gather the output, and I will see the aggregate value, where I will try to see that for which class it is giving me more weightage. So if for heart disease, if it's giving me more instances, more tree decision tree is giving more output as yes, so I will, as a final output, I will give this uh, as a yes value. So this will come under the bagging concept, where I am using bootstrapping of data plus aggregation of output value to deliver the result. Okay, now on the only other thing that we can tweak out here is the number of change of variables. So that is also taken care by random forest itself, where for a given data set and with an m number of variables, it can choose any number of random number of variables to build its random forest. So but at the same time it will check its own accuracy also and select the best random forest which provide the best accuracy. So that's the overview of random forest. What I will do is I will just show you a sample uh, fast code snippet of how to do random forest. Then we'll go for AdaBoost. Okay, uh, let me change the screen. If you have any question, please type that in the chat. Um, Okay, so I'm writing simple basic codes of random forest, but there's a lot of sources available outside where you can dig deep in random forest. So I'm just first importing some libraries, some basic libraries. So it will be like uh, numpy as np, import pandas as pd, and matplotlib dot pyplot as plt. So while it runs, so I have a data set of position salary. So let me show you how it look like. Okay, and we'll do data.head. So it's a small data set where I have a position, I have a level, and I have a salary for that. Now what I do is I'm not that much interested in position, but level salary. From there I can make a kind of regressor here, random forest regressor. Okay, one more important thing. Most of the algorithms that you see in machine learning, they can be tweaked for regressor as well as classification as well. So both these two type of problems we can do that. There's certain algorithm which is specifically for classification, like logistic regression or SVM. And there are specific algorithms which like linear regression specifically for regression. But decision tree, random forest, AdaBoost, gradient descent, these are some algorithms which come little more advanced compared to those basic ones. They can do both regression as well as classification problems as well. So here we are mostly looking at regression thing. Uh, so I have certain levels, I have salary, and for that each level I have a certain kind of position. So but for my data that we are having, so I'll just take only level and salary call. So do that to do that I will just take x as only level value and y dot using iloc, and this is the final 2 as the salary value, 1 is the level, and here I should do this. And so x will have just to show you what x will look like, print x. So it will show 1 2 3 4 9 10, like it is like that. This is the levels that we are having, and print y. If you do this, this will be the salary that we are having. Now once we have x and y, we will basically apply a random forest regressor on that. So random forest regressor. So for sorry, I just need to import a library. So the library we are taking from sklearn, from sklearn dot ensemble. It's command ensemble techniques. That is, we are considering multiple samples before giving a final output. Random forest regressor. If we do this, I import that, and then I will create a regressor object. So I will do that using regressor, random forest regressor, and some parameters, an estimator. So we are defining the how many trees we want. If we so we can put, I just put 10 here, but if you can put 100 and more than that, depends on the number of trees that you want. And we just fit the model. So fitting to fit the model, we just do regressor dot fit function, and we parse input and output variable. So all the process that we have discussed till now, it's happening just like that in the regressor.fit, where it is creating bootstrap multiple decision trees, building bootstrap data sets, and all those processes has been done directly in the backend. And if we just want to predict something, so let's say regressor.predict, because regressor is the model that we are having, and let's say I want to predict for the class 6.5. So we have levels 1 to 10 here, but let's say I will want to get 6.5. So what will be my salary? So to do that, if I just do print, I will get 1,67,000. So as we can see that as the level is increasing, salaries are also increasing. So based on that, it is the random forest regressor identify that for 6.5 level, if there's some level like that, my prediction, my salary would be 1,67,000. Now just to plot that how the random forest thing is actually predicting that and how this stage is going on, let me simply show you how to plot it. So np.arrange min-x. Okay, so whatever, when I'm doing the plotting part of this, usually this thing will not come in exams, or no one will ask mostly in competition. It's just for the demonstration purpose, for you to understand how the data will be look like. So grid data, x grid data dot reshape. Let me quickly write this one. Length of x grid data, and I will plot scatter. Plot scatter will do define all the values with color into red, and then plt.plot, which will do so based on the minimum and highest value we are trying to do that. Regressor.predict, for each data point in training we are trying to predict those value. So regressor.predict and x grid data color equal to, let's say, and just let me give the title random forest regression and x label and y label. Position, x will be the position and y will be the salary. And if I use plt.show, if I do this, it will show like this. So what it's happening here is, so it is showing how step by step how the values has been increased, and these steps also show that how the trees has been built over the progression. So the steps that you're seeing and the plots that you're having, these red dots are actually the actual data points from the data set, and the random, this step by step that you're seeing is basically how the decision tree has been made over the period of process, different kind of regression decision trees, and which combine together random forest. So that's how you can do a basic random forest thing. So in short, random forest regression is actually considered the one of the best classification regression algorithm because of the randomness, because it considers multiple aspect which for the data set, which brings due to its randomness nature of selecting the different kind of variables to build the decision trees. uh, so random forest, if you're trying to build any machine learning algorithm, mostly supervised machine learning algorithms and all that, it's better to choose random forest. Now let's go and talk about the AdaBoost before we'll go to, then after that we'll go to gradient descent, so gradient boosting. Let me see if we have someone has question. I will share the YouTube channel link on the later, or you can check that link from the what you say in the uh, I think these sessions are the live interaction sessions are there in the Swayam portal. There you can check that as well. Okay, so let me stop presenting and let's discuss AdaBoost first and see how things will go from here. Okay, let me share the screen. Okay, so AdaBoost, it also based and dependent on decision tree as well. But it's slightly different concept from what we have seen in random forest, and it's quite interesting that how it still give one of the best performance. Machine learning algorithm is one of the best, give better performance in terms of that. So what you will do is, when you take a random forest, okay, when you try to make a tree, it might be a full size tree. That means full size tree means it will try to consider as many as variable is taken taken in the concentration and try to make its best decision tree based on that. But AdaBoost is not like that, and plus random for doesn't have a predetermined depth for any of these trees that is creating. But AdaBoost, what is do is AdaBoost will make trees, decision trees, but the only difference that will have is it will create a tree with one node and two leaves. So we will, which will call it as, so just this is the one decision tree. It will make like this hundreds of different decision tree, but this will the basic structure for all decision trees having. That means it's fixed. There are only three nodes. One, the whatever the variable you're having, and based on that, what is the output that you are having. That's it. And this decision tree we call it as stump. This is a stump that we are having. Now, few problems with this stump are is obviously uh, it's not great at making classification, good classification, and it only uses one variable at a time to make a decision. So basically, they are called the another name for stump is weak learners. But 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 there's a the beauty of this algorithm, AdaBoost algorithm, is it will take weak learners. So let me draw like this. It will take weak learners like that, and combiningly it will try to make a strong learner with respect to that. So how he do that? So uh, so what it will do is, in random forest when we are trying to make a tree, they all are independent to each other. So because of their algorithm that they are having. But here when I'm saying we have weak learners, this this tree is dependent on output of this tree. Okay, so let's say tree T1, T2, T3 and T4. So T2 is dependent on T1, T2, T3 is dependent on T3 is dependent on T2, and T3 output, T4 output, T4 is dependent on T3 output. So what does it means is, when it try to create a first stump, it will predict something. Okay, now what it will do, it will make some errors. Now when it try to create another stump like that, the next stump, it will consider the errors which first stump make. Okay, and then again try to make a this again try to make this stump. Now once it does, then try to, it will also have some errors. Now what it will do, it will based on the errors that you are having, errors, again it will consider these errors, and then based on, to rectify those errors that is coming, it will to create third stump. Like that fourth stump will come, and vice versa. So what it will do, based on the errors generated by the previous stump, the new stump will consider those errors, and based on that try to fixate those problems that is arriving at this while creating the new stump. So basically it what it will do is, in three level step, how three main ideas of AdaBoost here is, first it will create a weak learners, okay, which is called stump. It will combine them Okay, it will combine them to make a strong learner. Okay, and while making, they all are related. Okay, so that is first point. Second point is, another important point is, when we say the random forest, each decision tree is gave the same weightage. But when we are creating this kind of stumps, three, four, or hundreds of stumps, some stumps get more say in the classification. We will talk about that. What is what more say and less say than others. That means some stumps, let's say this third stump that we are having, might have more weightage than the fourth stump or the second stump that we are having. The third stump might have more weightage. So whatever the output I am getting from this third stump, I will give maybe 0.5, 0.6 kind of weightage, and the fourth and second stump that I am created, I might give 0.2 or 0.1 weightage. So we will discuss that also, but this is the interesting aspect of AdaBoost. This is second point. Third point is, each stump is made by taking the previous stump mistake into account. So like I said earlier, in this, I will make stump number 1, that the decision tree number 1. I will predict something, I will get some errors. Now I will, while creating the new stump, I will consider these errors first. This will be my first priority, to fixate this error, try to predict these errors properly. Now once I create it, again some errors will come. So again the third stump will try to fix the errors which is coming in the second stump, like that. So that's how one weak learner will try to learn from the another weak learner, like that. So these are the three main points of the AdaBoost. So first we try to create weak learners, that is they consist of only 3 nodes. We try to combine them, make strong learners. Some stumps in the classification will have more say than the others. So when this will be more understandable here. Okay, so if we make this is the random forest. Okay, in this I might have number of trees, but each has weight equal to 1. So that's why when I'm trying to predict output, I'm considering that that 50 or out of 100 decision trees, 60 trees are saying that it is a hard disease. So when I'm saying that 60 trees have equal weightage of 1, but if I give the same problem to the AdaBoost, it and 60 will say yes also, but each decision tree, or in this case stump, will have a different weightage. So that is something we need to consider. And then third point is, each stump is made by taking previous stump mistake into account. That's how it is building the other thing, the new stumps or the new weak learners. So let's take an example for that again. Same the heart disease example we will take. So we have chest pain, block arteries, patient weight, and heart disease. So these here 3 are a variable and heart disease are target variable. So what it will try to do is, it for each sample, let's say we have some samples here 9, 10, something like that. For each sample it will assign some weight. So since the first point, it might give 1 by n. So n will be the number of samples. So 1 by n, 1 by n, like that. Okay. Now that's the first thing. So it will assign same weights. Now what it will try to do is, it will select any one of the variables from this thing. So let's say assume I am taking chest pain as the first variable to make a stump. So what I will do, I will take chest pain, and from there I will try to predict heart disease yes or heart disease no. DCS as no. So here I will do some correct classification, incorrect classification in both the cases. Correct, incorrect classifications. I might do this. So I might get certain values for this while testing this thing. Okay, I might get certain values. Now my focus is, and then after that I will try to calculate. I will calculate Gini index, which tells us that whether how good this particular stump will be like. So similarly for others, other variable, in this case the block arteries and patient weight, I will also try to create arteries and patient weight, right? I will try to create this term and then I will try to calculate Gini index. So whichever out of these three variables, Gini trees terms, I might get the less Gini index. I will choose that as my first term. Now once I get the first term, this is something concept called total error. Now what this total error will say that for a stump, the the sum of weights associated with the incorrect classified sample. So like I said, once we calculate Gini index and we found the stuff with the less Gini index, we now focus on incorrect samples. Now once we get the incorrect samples, we try to incorrect samples, then what we say, based on that we try to give certain weightage to that incorrect sample such that it will be passed on to new stumps whenever you're going to make the new stump for that. So for that there is something called as amount of say, which is amount of say which is equal to amount of say of that sample or that instance in the new stump. So when we have this, so we will write 1 minus total error by total error. So the total error will be the weight of that incorrect sample during that iteration of that process. So in the first attempt, so we might have 1 by n sample weights. So we will take that and we'll put this in this formula. Okay. Now once you have this amount of say, so what based on that what we'll do is, in the next cycle, that is the next cycle of making stump, we try to find new sample weights. Now new sample weight will be the sample weight of this cycle into e raised to amount of say. This is for incorrect samples. Okay, so usually if we have, and you check that the amount of say is here is positive, but for correct samples which are correctly classified, the new sample weight will be sample weight into e raised to minus amount of say. So what these equations will do is, for incorrect sample, it will try to give high weightage, and for correct sample which has been classified correctly, it will lower down its weight, such that the new term will focus on more on incorrect sample rather than the correctly classified sample. Okay, so like that the process will go on, and so once you get this incorrect something like sample, so how the table will look like actually. So let me show you here. Chest pain, block arteries, and patient weight, heart disease. Okay, now here sample weight, let's say. So sample weight 1 will, when we are trying to make a first sample, first stump. So I will have 1 by n as by sample for all the samples. Now sample weight 2 will come after that, where suppose this, the third column is incorrectly classified. So in this case, this sample will be the new sample weight, let's say k, will be greater than 1 by n, and let's suppose this 5, out of these 5 samples which are correctly classified, 4 are correctly classified, their sample weight will be less than 1 by n. So what will happen because of this? I will have higher sample weight. So when I try to create new stump, it will consider this value with more weightage, and then it try to classify it again. Now the classification process will be same, where since we have only one stump, so with this high new sample weight, it will choose each of these variables and try to see predict which one is giving better prediction for the heart disease using Gini index, and like that the process will go on. So like that it will do. Now how it will give a classification at the end? So what it will do is, so let's suppose it has to give heart disease or not. So I have some sample of stuff here and sample of stuff here. So if I have heart disease, yes, and here no. Okay, so for all the stumps which is saying yes, I will check the amount of say for all of these stumps which are saying yes, and I will check the stumps amount of say of uh, all the stumps which are saying no. Then I will try to aggregate them. Aggregate here is basically means adding the amount of say for all the stumps that we are saying yes, and then we will just check that whether it is greater or less than in this case. So if the amount of say for hard is yes is more than no, then we will give the final prediction as yes. If the heart of if the amount of say of no heart disease of stumps which saying no is more than uh, the number of stumps which saying yes, then we will say as a final result as no. So that's how the AdaBoost algorithm works. So to summarize again, what AdaBoost do is, it will take a decision tree. Now decision tree is basically consists of three nodes, which will be called as stump, where the variable will be there, and it will just give the output as yes or no. Okay, now these are called weak learners, and it will try to build multiple weak learners on top of that, where the weak learner 2 will try to learn from the mistake of weak learner 1. Similarly, weak learner 3 will try to learn from the mistake of weak number 2, and vice versa. Now once we are trying to we combine all them to make a strong learner. So what it will try to do is, uh, it will combine all the work to make strong learners, and also at the same time we are also calculating something called amount of say for each stump. So a particular stump might have more weightage of saying in the final output decision than some other stump. So that is another important property. The important property is it always consider errors of previous stumps. Now what it will do is, to understand the amount of stay and all that, it gives sample weightage to all the, it will try to give sample weightage to all the individual instances. Once it's do that, like same weightage, it try to make us initial stump. Now once it create an initial stump for all the variables, because we have only three nodes, so it will consider only one variable at a time, and then it will calculate the Gini index for that. So whichever give the less Gini index or less Gini error, it will select that as a one of first step. Now once you have this, it try to calculate the error. Now once it calculate the error, the samples which errors basically the it try to find the error samples which are incorrectly classified, and it will collect all its sample weight. From that, try to calculate the amount of say in that. Now once you calculate amount of say using this formula, you try to calculate new sample weights for incorrect samples, classified sample, and correctly classified samples. So mostly what will happen is incorrectly classified samples will have more weight and correctly classified sample will have less weight. Now once you have this, you will get the new sample weights, and based on new sample weights you try to create a stump, and like that you treat this for hundreds of time. Now once you want to predict something, what it will do is, uh, from value of variable, it will try to uh, iterate to all the stumps and will try to see that which of the stump will say yes for the heart disease and which of the stumps will saying no for the heart disease, and then it will try to aggregate the amount of say for all those stumps, and combiningly whichever class will give higher amount of say, the model will predict that. So that's the overview of AdaBoost. Let's code it out also. So let me stop sharing the screen here and just give me a minute. Let me put this my iPad on the charger such that it will not lose out, because I have to discuss gradient boosting as well. So give me a minute for that. After that we will do simple coding for AdaBoost. After that we'll take a 10 minutes break. Just give me a minute. Till 8 o'clock. Just stay till 7:15 possible. After that. Yeah, sorry for the delay. Yeah, any other ensemble methods we need to learn except AdaBoost? There are multiple ensemble methods, are there lot. But I'm telling the generic and the most common one for you to start with. Uh, in this case, as AdaBoost and Gradient Boosting. But a lot are there. If we just check for ensemble methods, hundreds of ensemble methods you will might find. So that vast type of algorithms that we are having, but these are mostly used one to solve the problem. Now let me share the screen and quickly let's type it out, the AdaBoost algorithm. Okay, so let me import pandas because pandas as PD. Now we are taking a data set for the breast cancer one. So let me take read CSV WBC data data.csv. Now df dot head. Let me show you the data set here. Okay, so it's basically for the data set is breast cancer data set. So it shows a diagnosis which is a target variable. It has two types. M means malignant and B is benign. So malignant is more serious. Benign means B. It is less serious. And with that, lots of variables are there with respect to the cancer cell that is have. So lots of points are there with respect to this. Now we have this data, and let me tell you what is the shape of the data set. So if you want to know data set, just df dot shape. If you do this, that is more than enough. We have 569 rows with 33 features. So 569 instances we are having. Now we are just going to remove certain rows columns here, in this case ID and and unnamed 32 as this columns because they are not necessary for our analysis. So let me do that. So for do that we do df dot drop and then we mention the row name, say column name. So this is unnamed 32, and then if you put access equal to 1 it will remove the whole column. Now it has removed that, and then we will take target and feature variables for training and testing. To do this we just I will take diagnosis column, I will take its value in y, and I will just drop the diagnosis column from x. Diagnosis. So we're just dropping this as that all other variables will be our features. X is equal to 1 dot values. Okay, so we have created like that. Now we are going to use label encoder. This is because we have uh, diagnosis target field as m and b. So instead of that we will just keep it 0 and 1. To do that we will use method called label encoder. Okay, so for this let me create a object label encoder. So I'm creating an object of label encoder, and I am trying to fit label encoder with fit and transform. So label encoder will look at this value of m and b and this convert it to 0 and 1. So once we do this, then we will do train test split. So we do that with sklearn.model selection, import train test split. Okay, now once we do this, now let's train test split the data. Do that, we'll define some variable xtrain, xtest. That's the typical process that we usually follow. Y test, then we call it train test split. In this we have to pass input variable and target variable. Then to split that to have a proper balanced set, we will have stratify as a stratify as one of the variable. Otherwise you can put test size as 0.3 as well, or 0.25, whatever you wish to do. Then we will have random state as 0 for reproducing the output. Now let's run this. Now okay, yeah. Now once we have this, now we just have to build the decision tree model from it. So first, okay, so what we'll do is we will build a decision tree as well, and we'll build the AdaBoost because AdaBoost is built on top of decision tree. So we will do the both to see the accuracy of how good AdaBoost becomes when it takes multiple decision tree rather than taking one single decision tree. So let's put sklearn tree import decision tree classifier, and I'm making an object for that. So decision classifier. In this, we are just trying to get depth of 1. So same as AdaBoost concept. The only thing is we are not using AdaBoost algorithm to define it. We're just creating like that. And let's run this, and we try to fit tree dot fit x train y train. So this will fit that, and then we do some prediction. So y train prediction. So to do that, you just do tree dot predict x train. Then we will do y test prediction, tree dot predict y train. Sorry, x test, right? Y test is there. So x test give. Now once we get this, we just have to do find accuracy score for this. So let's find out from sklearn.metrics, import accuracy score, and in this we will do find the accuracy of t train, that is training data, accuracy of training data, accuracy score, and y train and y train predicted value, and tree test accuracy score of y test and y test spread. And just let's print the value. So printing the value, I'm just writing quickly f decision tree or test accuracies. In this tree train dot 3f or tree test till floating point of 3. Once we run this, okay, so for accuracy for decision tree for training data, is 0.925, and for test it is 0.874. That means at 92% of the cases it quickly predicting the test train data. It's almost good, almost in the range of overfitting, and test accuracy it's able to less do that, which is quite okay with this, because this is a decent one. Now once we know this accuracy for the decision tree train with max depth of 1 only, let's make a AdaBoost here. So building the AdaBoost model. So for this we will take from sklearn.ensemble import AdaBoost classifier. Let's put some parameters for AdaBoost classifier. So it contains base estimator, which is a base simple tree that we are taking. The tree is the one which we defined earlier, and estimators, it may make till 500 trees. Learning rate, we haven't discussed much on the effects of learning rate in AdaBoost, but we'll surely will talk that in gradient boosting as well in that, because it has a more better instance for that. Once we create this, then ada is equal to ada dot fit xtrain ytrain. So once we do this, again same concept. So let me copy a few things here from there. So we start with, okay, ytrain pred, and find the test accuracy score for training and testing data. And let's print the output as well. Okay, so let me change few things here. So instead of 3, let me take it as ADA, ADA, and I think here I'll just do area test. Okay. ADA and ADA. So what I did here is, again I'm predicting the white train and white test data using the AdaBoost algorithm, and then we are trying to calculate the accuracy score, and we just printing it out. So for ADA train it is almost 1, which is accuracy, that means almost fitting the data, and for oh, and for test, and for the testing data it's almost 0.98, that means it actually overfitting the data. Ideally should be the case, but for this data set that we are having, it is giving this, but still it gives a better accuracy in most of the situations, approx in the range of 80s, late 80s or 90s, early 90s to do that. So again, to summarize, what we have done here is we are trying to create a AdaBoost algorithm. For that, we have taken a breast cancer data on which we try to uh, compare the performance of decision tree and AdaBoost. So decision tree, we take only single tree with one depth, and for that we find accuracy of approx 90% of accuracy. But if you take AdaBoost, which is built upon the cases of weak learners, at that point of time, the decision tree accuracy is almost 1, which is almost 100%. That means it is actually overfitting the data. But at the same time, for test data also, it is giving almost 99% of accuracy. But this is depending on this data set case only. If we try new different kind of cases, the this thing might varies from data set to data set. Okay, let me. So we have discussed two uh, things till now. That is, first is random forest, and other is AdaBoost. Now we will take a short break, maybe for 10 minutes, and then we'll finally discuss the gradient boosting algorithm, which is actually an enhanced version of the AdaBoost and random forest. Okay, so okay, someone say, okay, I have to check that. I haven't seen that because first time I'm getting notified. Link 5, right? Session 5. Let me check what is this session 5 is. I'll get back to you after a short break. Okay, and I will check whether I have if this is genuine problem, I'll try to fix it. Okay, so we will come at 7:25. Okay. Hi Sanjeev. Yes, you are correct. I'm not able to uh, proceed based on the YouTube that link. So what I will do is I will again try to upload and change the link. If that's not working, I will re-record it. But the meantime, that in that class we have discussed about central limit theorem, confidence level, hypothesis testing, type 1, type 2 errors. So let me give you the sheet on which we worked on that so that you can along with the answer. So let me do this. Okay, I've just shared that Google Drive link with you. Okay, I haven't shared this thing as well, right? Google Collab link. Let me share that. I'll share the Google Collab link as well. Okay, so it's almost 7:25. So let me share the screen. It's already done. Okay. So we will talk about now gradient descent. Gradient boosting, not descent. Um, okay, so gradient boosting. So we will discuss about that. So let me also. Okay. Now gradient boosting. So it's the specialty or the observation of this gradient boosting is in most of the competition, ML related competition. This algorithm has been used uh, a lot of times to win the competition. So if they have a lot of ML competition happening around the world where they give some problem statement, and it has been observed that if you want to use that, there's a high chance that if you the winners are always apply gradient boosting in their solutions. So because it gives much more effective accuracy over the other ML algorithms out there. So let's see what this gradient boosting is. So it's a separate version of ADA boosting with certain tweaks and thing, but the concept is basically same. So in ADA boost, we create a stump which is consist of three nodes only. In gradient boosting, we also make a decision tree, but the only difference with that is it will be greater than that. It will be greater than stem, okay, greater in size, but in similarity what it will have is all the decision trees, all the d tree are of same height. Okay, so it builds the fixed size trees like AdaBoost as well, but the size of the trees is something we need to define, or we have to define it, or it will take some predefined value. So the predefined value comes down for the number of leaves that we want, the number of leaves. So in this case, I have taken a tree of 4 leaves. So based on that, it will create a tree of depth 2. If you want to create 8 leaves, then I will create a depth of addition tree of depth 3, like that. So the major difference, one of the major differences, and similarity also differences, it will not be a single stump, but usually bigger in size. At the same time, all the condition tree in gradient boosting are the same size of fixed sizes. Okay. uh, it also scales the tree. So when we are scaling, that means in ADA boosting we are trying to have something called as amount of say. So amount of say is basically a kind of weightage or scaling parameter they are giving for a particular stump or particular stump, right? In this also we will have some amount of say kind of variable, but this amount of say will be equal to all decision tree. It's equal to all the decision trees. So here amount of say is basically the learning rate. Basically learning rate. Here the learning rate is equal to all the decision tree that we are going to do that. Okay, so this is some of the parameters, this thing. And gradient boosting also, like ADA boosting, will build the trees till the till certain, like till it gives the same kind of output, or try to improve, it fails to improve the fit, or improving additional tree will not improving the accuracy of that particular gradient boosting trees, like that. So to start with, uh, gradient boosting as this, let's suppose an example. So example will be like height, which might be in meters. A person might have favorite color, gender. So based on these three parameters, we have to predict what is the weight of that person, like that. So these are the features, and this is the target variable. So it's a kind of, so again gradient boosting can also do the regression and the classification part. This example that I am telling you, it's more into regression part, like that. Now what it will do is, so how the gradient boosting process start, boosting process. So first step is step 1. It will take a leaf with a certain value. What certain value? With the target variable that we're taking, we will take a average value of target variable. In this case is weight, target variable, in this case average weight. So let's assume 71.2, something like that. So this will be the leaf, first leaf. Now what the gradient boosting will do is, it will try to generate a tree. Okay, so we will have n number of samples here, and it will try to generate the tree out of it. Okay, now the influence of that weight will be, in this case, will depend upon the residuals. So once we have this average weight, what we'll try to do is, in the step 1, once we calculate this, we will take the residual value. That means this is the observed and this is the predicted value. So the step 1, since we are assuming the average weight for that, so we will get some values here, this residual value. Now from this residual value, we'll try to build the tree. So what does it means is, with height, favorite color, gender, we'll try to make predict of the residual value rather than the weights here. Okay, so for example, if I have weight of 88 here, so 88 minus 71.2, 16 point something, 8, 16.8 here. So I will try to, for this instance of values, I try to create a decision tree where I try to fit with particular feature value, I try to predict 16.8 value at some point of decision tree, like that. So here more focus on residual rather than on the actual target variable. We are focusing on residual of the target variable in this case. Now once we get this, what we'll do is, so like 71.2 plus I have some decision tree. Let's suppose I have created this decision tree like this. Now what gradient boosting will do is, now I try to again predict the value. Okay, so the values present at the leaves, it will take that. So what it will do, for all the instances, that is height, color, gender and weight. Okay, so what we'll do, based on this input instance value, and this is new predicted value, it will do 71.2 plus whatever the values you're going to get from this decision tree value. Okay, so we will take that, and that basically we will take that as a residual, whatever the residual value will be, and this will be predicted weight for the particular instance. Like that, it will do the prediction for all the instances with this. Now what will happen is, we'll get the new set of predicted value. New set of predicted value. From this again we try to calculate the residual. So some residual will come. Again what we'll do is based on this residual value we try to build a decision tree based on this residual value. So again it will try to create a new decision tree based on the current residual value. So what it will do again, it will during prediction 71.1 or 71.2, that is the first predicted value that we have taken, then the first decision tree that we have taken, then second decision tree, this current decision tree, we will take that. No, so what will happen over the period of time is, since we are calculating residual, over the period of time we will take n number of decision tree to make it closer to the actual observed value. So for example my weight is 88 and initially during initial prediction I got 71.2 something like that, 74.2. Then with this first decision tree my weight might be increased to 75.1. Then with second decision tree, because I'm adding the residual from here, these are all residual trees, residual decision trees. My value might increase from 75 to 76.8 something like that. It will keep on increasing till my weight will reach around near 88, like above or below. So this is the iterative process that will keep on happening in the loop. Now the beauty of this is, once you're doing this, we also try to give a certain kind of scaling to that. Why? There's a chance that if I don't give scale, the first decision tree itself will give me a direct residual. So instead of this, that means after 71.2, I might directly get 16.8 and it will give me the value of 88. But if I do this, my data will be overfit. So what it will do, it try to slowly learn those values. So what it will do, it will try to scale. That's where the learning rate parameter will come into picture. So let's say, assume I have 0.1 as a value. So what it will do is 16.1, 0.1 into the decision tree. Again, since the scaling value is same for all decision trees, we'll keep, whenever the new value, new decision tree I'm building, it will keep on scale with the 0.1. So now in this scenario, my weight is 88, and if I have to calculate with decision tree, so let's suppose 16.8 is directly is giving. What it will do is 0.1 into 16.8. It will do, and some calculation will come where it rounds to 72 point something, because 0.1 it reduced the weight from 88 to 72, 72.5, let's assume like that right now. Once you have this, again the new residual value will come. Here might be 15.3, let's assume. So because of this my value will increase to 74.3, like that. So slowly it is increasing, and now it has been observed that since if you slowly reduce the residual, its predicting capability will improve drastically. So rather than directly overfitting the data, it is trying to slowly improve its predicted value over the period of time through using of learning rate. Okay, so that's how differently it works from the AdaBoost. So it's mostly focused on the residual tree. That means first it will take an average value from which it try to find a residual. Now from this residual it try to make a decision tree from where it will find some new residual, because a decision tree plus into learning rate, then learn residual 2. From there again it try to create a decision tree based on this residual 2, adding learning rate I might find residual 3. Likewise, I will keep on making new decision trees till the point I might able to predict my mm, my values, my weight in this case properly. Okay, so since we are doing this small step, is basically a small step. We start with certain way, then we again slowly increase the value using learning rate. Again, it's like a step based thing. The only difference is the step here might be here in this case is learning rate, in this case 0.1. So I might have a huge learning step in terms of certain values. I might have small step in terms of certain values. That depends on the decision tree that you are making. So we keep making these kind of trees till we reach the max specified value, that is in this case 88. So we try to reach 88. So there's a chance that sometime my value of 88 will be more or less like that. So this helps a lot in the predicting the value. So in summary, how the gradient boosting work is: first point, we start the leaf, which is the average value of the target variable. Then we add a tree, decision tree basically here, based on the residual. Okay, residual is observed minus predicted. Okay, based on residual values, and we scale the tree contribution to the final prediction with a learning rate. And then third step will be, then we add another tree based on new residue that we have found, and we keep adding trees based on the error made by previous tree. So that's the overview algorithm of gradient boosting. Okay, now what we'll do, we will start, I quickly code this gradient boosting with this small sample size, and that's how we end the session. Or if you have any question with respect to what to do after this course, we will discuss briefly that as well. So let me switch to computer and okay, yeah, I think it's visible now. Let me import some libraries here. So libraries are some min-max scaler, scaling pre-processing, scaler, then scaler, ensemble, import gradient boosting classifier. Now since it's running there, so we have a Titanic dataset. So this Titanic dataset is one of the famous dataset where trying to predict that whether a particular person will drown or not in the sea. So we have train data. So it comes usually directly as two data set, as train and test, rather than giving one. So let me write train.csv and test data pd.read csv test.csv. Why it is not running? It's taking time. Okay, let me say it's again connecting. Let it connect. So we'll take that train and test data. Uh, Let me show you how the train data is. Train data dot head. It has been run. This has been run. This has been run. Okay. So we have few things. It's a name whether they survive or not. P class I don't remember right now, but it has its sex, it has age, siblings, uh, patch I don't remember, ticket number, fare, cabin, and mark. So just telling that for a Titanic, that famous Titanic ship which drowned, so just giving us the data set, uh, which person has been survived and what are the condition of their survival. So like the test data is pretty same. So what our value of interest is whether person is survive or not. So this is a target variable. So let me take that from y train. So y train is equal to train data survived, and we are dropping train data drop survive column. Survive access 1 in place true. That's our data. Now we are taking, instead of test train test data, we are taking directly here because we later split it apparently. So we are taking full data. So we're just appending the test data with train data. Train data append test data. Once we have this, now if we do full data dot shape, we have approx 13,000, 1300 instances with 11 features. Now what we do is we are going to drop certain columns which are not required in our full data. Full data in this case will be our actual feature variable. So let me drop certain columns which are 11 for us. So the process that I am doing is almost same for almost all the classifier regressor that you're going to make. You take only relevant data for your classifier. Cabin and patch embarked. So I do this and full data dot drop labels equal to drop columns access 1 in place true. Okay. Okay, now once we did this, um, so we do some pre-processing of data. So in this, what we'll do is we keep the sex column. So wherever the values are empty there, so we'll give some dummy data from there. So it will analyze the full data from, and it will fill the values in the sex column. So once we have this, then dot fill na. So wherever the value of na is present, not empty na is different. So we're just giving value 0.0, and we're doing in place true. Now since we know already the shape of data, I'm directly doing train test splitting. We can do manually as well. So train and test split. So in this we can do xtrain scalar dot fit. Okay, so scalar value will try to normalize all the values to a certain range because multiple values are there. So it will do that. Okay, I have to do first train test split, right? Sorry, my bad. So I have to do full data dot values, and I might take some random value like 991, 891, some random value. I'm not doing the train test split here. Full data dot values 891 like this. Let's do this and let's do the normalization of the data. So I will do xtrain scalar dot fit dot transform xtrain, then xtest equal to scalar dot transform xtest till it runs. Now we will, okay, once we did that also train testing data as well, but still we need for y train and y test data. So let's do the train testing split here as well. I think I can skip that value of 891. I can directly do here as well. Y train, y value. So y value is basically instead of test, we are doing validation kind of thing. Let's split x train, y train. Test size, random states, and finally, since we talk about learning rate a lot during the discussion of gradient boosting, what I do is that directly rather than predicting, I will show you the output of all the gradient boosting trees that we are finding with different number of different learning rates and how it changes the accuracy for that. So let me write few options of that. 75 now for learning rate in LR list. GB is gradient boosting, CLF is classifier, and we are calling the gradient boosting classifier with estimators of 20 trees learning rate will be equal to learning rate. Each learning rate from LRS it will take max features that it can extract. Next two variables it will consider time and depth of the tree at the time it's fixed, that is 2 we are giving, that is 4 leaves, and random state we are giving equal to 0. So each decision tree that we have said in gradient boosting is same with same depth and same number of features, not like random forest, so we are not going to do that here. So that is also one of the major difference between random forest and gradient boosting classifier. Once we do this, then we do X train and Y train. We are fitting that data. So by the time it will do, now we just have to print it. So let me print learning rate print accuracy score in training. So for that we can write 0 using format value here, and format will be gb.clf dot score extreme y train, and print accuracy score for testing, so validation, zero dot 3f dot format gbclf score y. Okay, okay, I think I have to do for all the type, right? So it is better to put it here. Okay, so for each learning rate we can find training validation score for that, accuracy score. So let me see which one gives the better result here. Okay, so this important thing that as we increase the learning rate, our accuracy score is increasing, but again we have to check the trade-off overfitting versus uh, getting a trade-off between overfitting and keeping the model as generalizable as possible. So if you're thinking that our accuracy score has been increasing a lot, it might be lead to overfitting, like we have seen in AdaBoost where accuracy score is exactly 1. So we have to change our parameters in a such a way that it will accommodate new samples as well, because it's training, it is working perfectly for training data set, it is properly classifying the training data set, but when it comes to new data points there might be very different from the training data set, there it might fail. So we have to check those kind of things as well. uh, After that you can obviously you can work upon the confusion matrix classification report directly by using the confusion matrix function, classification matrix function. I'm not doing for this stick. So so just to summarize, gradient boosting algorithm, it's slightly different from ADA boosting, but it is one of the most famous algorithms where it comes to give proper accuracy, where it try to create trees of same size, but it use the function of learning rate to create a decision tree based on that. Uh, and then we discuss the AdaBoost, and which focus on stump, that is it takes weak learners and from weak learners try to make strong learners. And then there's a random forest where uh, from the data set manipulation to the selecting different kind of variables for create decision tree, everything is randomized. So these three are one of the most popular algorithms right now in the ML space, where tried, and they work for both regression and classification. So that's it from my side from this aspect. Let me check if someone has question. Can I break IPS co-match? If yes, which model will be best? Gradient boosting algorithm will work. Yeah, you can try it for gradient boosting a random forest. I think they both can give you better answer for that. And I think there's a, if you check for Kaggle.com, there might be IPL prediction will be there. Let me check once. IPL prediction Kaggle. Okay, so let me show you the problem statement as well. It's one of the famous problem statement. Okay, you check this Kaggle IPL match prediction. So it has its own data as well, discussion leaderboard. So you can check the other kind of solution also which people have seen for that. Uh, okay, I already shared this Google Colab. I'm again sharing this with you. You can make a copy of that if you want to check this stuff. So a lot of match prediction thing or the other real-time based questions are there in Kaggle. So you people must try it out Kaggle for that. And like I said earlier also in most of my interaction sessions, that if you want to improve your data analysis skills and machine learning, and if you want to go beyond that, which is come down to neural networks and all that, you should try it out kaggle.com. It's one of the best sites to learn, practice different kind of question. You will improve your coding skills. In there we try to solve some real based kind of problem with lots of data is available, and you can apply different kind of solutions as well. It has a very good community over there. You can try it out. And this course is mostly an introductory course where you try to look at from statistics. You start with the basic mean till you reach to machine learning. Now after this you will go for deep learning kind of thing where we have neural networks. In that LSTMs are there, something like LSTM, RNN, CNN, transformers, different kind of architectures are there which you can learn over the period of time, because everything is deal with how to understand the data in the best possible way. So all the statistic, the purpose statistic is that we have humongous of amount of data, how to understand it in a best possible way, and how to validate that whether data of understanding that we are getting is, does it actually make sense in real world or not. So it's all the purpose of statistics, and ML is one of its tools to make it and this analysis more faster, where instead of us analyzing the data, the machine will analyze the data for us, and based on that we will have to take a decision on that. So my takeaway from this course is, it's good to have basics and all mathematics around that. It's very good because once you start coding and you try to apply uh, this sklearn libraries, this libraries called TensorFlow and PyTorch. These are what were very these are very famous libraries that we are having, which you might use over the period of time if you're going to the world of machine learning um, and AI. You should check this out things. It has good tutorials. Let me these are I sent two libraries, TensorFlow and PyTorch. It's one of the most used libraries in the area of machine learning and AI. Please check them out. There are hundreds of tutorials are there only on in this website itself and other outside as well. Do it and please explore it, because analytic a few hundreds of data will not make sufficient. Once you come into industries and all that, you might deal with billions of data points, and there you need this kind of techniques, and there are hundreds of techniques out there. So you have to keep yourself updated from time to time. So but Kaggle is a good start from them. After that you might look at the TensorFlow and Python. These are the libraries which you can use to build this kind of algorithm that we have seen in this course, the machine learning algorithms. Or you want to, if you want to go towards other part, that is deep learning, There you can use this TensorFlow and PyTorch as well. So that's it from my side, and this is my last interaction session, and all the best for your exams. In your exam, mostly it will be computer based, I hope so, and you might get both kind of questions where you have to solve it on paper and you have to write the code as well. In the code, when you're trying to write the code, you just have to remember the function names, all that. You don't have to remember all the other aspect. You have to know how to pre-process the data, that is using pandas, and then how you have to remember the function names, which is just like in gradient booster classifier. You just have to remember the gradient booster classifier as a function name, and then you just have to use the fit function to make it run. And to evaluate the model, you have to use classification report and confusion matrix. So these are the few things that you need to aware of. So if you have any question, please let me know. Otherwise, the session is end from my side. Thank you so much. Yeah, thank you everyone. Okay, which algorithm can be used to trend between players in innings by innings data? Linear regression kind of algorithms. I will not say linear regression, multiple regression algorithms are there. You might use regression algorithms for that. But if you want to see that which team will going to win because it is yes or no, and based on multiple features, then you might have to use classification algorithm for that. Can you tell me what is PyQ? So can you tell me what is PyQ? Previous year question. There's no previous year questions from NPTEL. They are not even access to us also. Okay. Thank you everyone. Have a nice weekend ahead, and all the best for your exam.